Hello, students. Welcome to, this should say Skill 18 notes, not Skill 8. Whoops. All right. We've gotten way far into this semester, so we should definitely be way higher than Skill 8. Anyway, today's lesson is about Introduction to Logarithms. And so what we're going to do first is we're going to talk about the connection between the exponential and the logarithm. So first of all, know that the definition of an inverse in general, which we talked about earlier in the semester, was that you are to switch your input values, which are your x values, and your output values, which are your y values. And so what we're going to do is we're going to use that idea to help us find the inverse of the exponential function y equals 2 to the x. So we saw when graphing exponential functions that when we plug in negative numbers for x, we still had positive y values. Okay, so that's going to be important when we flip-flop these and we look at the inverse of this, okay? So what do you think the equation would look like if we switch the x and the y? So in other words, what kind of an equation would we have? So let me just kind of throw out a couple of things here. We know that in the past, when we had like y equals x squared, we know that when we did the inverse of that, we had x equals y squared. We knew that we could take the square root of both sides to get y equals the square root of x. And so we said that the square root function is the inverse of squaring something. Okay, and then even more primitive than that, when you first learned your basic math operations like adding, subtracting, multiplying, and dividing, we know if we had like y equals x minus 4, if we were to switch that around, we'd have x equals y minus 4. We'd have to add 4 to both sides, and we would see that adding is the inverse of subtracting. Okay, and then you could do a similar thing with multiplication and division. So if I had like y equals 3x, if I switch that around, we get x equals 3y. We would divide both sides by 3, and division was the inverse of multiplication. But the question becomes, well, what in the world is going to be the inverse of an exponential? How do I undo raising something to a power? Well, that's where this new concept is going to come in. That's why we are talking about some weird brand new word called logarithms. The inverse of this, what we would do is we're going to switch the x and the y around. And the way that we're going to get that y out of the exponent is we're going to do what's called the logarithm of the base of 2. We're going to do that to both sides. And what happens is that log base 2 cancels out with the 2, so we end up with y equals log base 2 of x. So that's going to be our equation that we use. All right. Okay, so the logarithm ends up being what we refer to as the inverse of an exponential. So, because we know that this is something that is completely foreign for most of you, let's start with the graphical perspectives. Y equals 2 to the x, we know that this is exponential growth. We know it's growth because we have a b value rather that is greater than 1. We also know that because there is no number being multiplied to the front, we can say we have an understood y-intercept of 1, which you can see from the graph that makes sense. And the graph is growing. And remember I made that connection. I said that even if we have negative exponents for x, the function itself does not go negative. So we have an asymptote here on the x-axis. Well, when we talk about the inverse function, notice that for the logarithm, none of our x values are negative numbers at all. Okay, they're all positive numbers no matter what y was. Okay, so what we notice here is we have a vertical asymptote on the y-axis, which means that x equals 0 is a vertical asymptote. So a consequence from this is that no logs can be negative. Okay, Now, those of you who have been with Riverside or Heron for a while, you know what logs are in terms of behavior. If you get a log for doing something bad, that is a negative thing, right? So we don't like those. We don't like negative logs. However, you can get commendations, which are positive logs. Those are good logs. So when we think about the graph of logarithms, we don't want the value of our input, so the x value, we don't want that value to ever be a negative number. Okay? It is not in the domain of the logarithmic function, which you'll learn more about in pre-calc, but just know that for now, we want logs to be positive, so no negative logs. Okay? All right, so as I've alluded to, the name for this inverse function is called a logarithm. A logarithm. Whoops, I'm misspelling it. There we go. It's a logarithm. When we write the inverse as x equals 2 to the y, that is not helpful because the y is not isolated. To write an equation with y isolated, we have something called log form that allows us to rewrite exponential equations. So the original, if we had y equals 2 to the x, when you switch x and y around, you get x equals 2 to the y. But when we write it in log form, we write it as y equals log base 2 of x. And I kind of explained that a few moments ago. So generally, if you have y equals a to the x, your log form will be y equals log base a of x. Okay, so to convert between the exponential and logarithmic forms, you'll just use this pattern. So this is the exponential form, and this is the logarithmic form. Notice it says that a has to be greater than 0, so we want our base number to be positive. A cannot be 1. We also notice that the y, so the input here, is going to be greater than 0. We don't want negative logs, remember that, okay? All right, so now what we're going to do is we're going to do some practice converting between them, okay? So here's an example. We have 5 to the x equals 25. If I were to rewrite that in logarithmic form, first thing I do is I identify the base, so the thing that I'm raising to an exponent. So in this case, I have 5 to the power of x, so 5 is my base. And so when I write it in log form, that becomes the subscript of the log, so log base 5. The exponent, so the exponent, this is what the log equals. So whenever you write the exponential in log form, whatever your exponent in the exponential form is, that is what the logarithm is equal to, which then means that the other piece goes with the logarithm. Now, for those that are like, oh gosh, this sounds confusing, here is a nice little handy dandy way to kind of help you. A loop conversion, okay? So if you have something written as log base a of b equals x, basically what happens when you convert that to the exponential form is you take this b, loop it over to the other side of the equal sign, take that x and make it become an exponent, and then your a becomes your base, okay? So don't worry, we're going to do a lot of practice with that, okay? All right, so if I convert, the first example here is to convert to logarithmic form. So I'm just going to follow the loop conversion here, okay? So, well, I kind of have to do it in reverse because right now these are in exponential form. We're going to start by writing the word log equals, log equals, log equals, log equals. Look for your base. In the exponential, the base is the thing that's being raised to an exponent, and that becomes your itty-bitty number with the log. Okay? Now remember, I told you a moment ago that the exponent is what the log equals. So whatever your exponent is, that goes to the other side of the equal sign. I may need more room on this one. I may need more room on this one as well. Here my exponent's 1/2, so that's what the log equals. And now the final piece is the number we didn't use yet gets put next to the log. So this will be 625. This will be 1 over 64. This one will be 9. And this one will be z. And that's how we're going to convert those from exponential to logarithmic form. So now let's go the other way. If we go the other way, here we can use that loop conversion. So here I know that I need to start with the base of 2. The 32 loops over here, and the 5 loops to become an exponent on the 2. So it'll look as such. Next one, I start with my base of 4. The 2 gets looped over here, and the exponent gets looped back here. So 4 to the 1/2 equals 2. Which we should know that anyway, because remember, 4 to the 1/2 is the same as saying square root of 4, which gives us 2. Next one, loop, loop. 2 to the -4 equals 1/16. Still true. Last one, loop, loop. X to the z equals y. That's how we convert between exponential and logarithmic forms. So now we're going to use these ideas to help us evaluate some logs. All of these are written in log form, so we can use our loop conversions. Okay, so to do this, loop, loop, 3 to the x equals 27. Well, now the question becomes, well, 3 to what power is 27? Well, that would be 3. The next one, we're going to do our loop conversion. We have 5 to the x equals 25. Well, 5 to what power is 25? Well, 5 squared is 25, so x is 2. Next one, we'll do our loop-de-loo. We have 1/2 to the x equals 1/8. Well, this one, ask yourself, 1/2 times 1/2 times 1/2 gives you 1/8. So that means that 1/2 had to be multiplied to itself 3 times. So x equals 3. If we look at the next one, we have, so we'll do our loop conversion. So 1/3 to the what power gives me 9. Well, this one's probably going to be a little bit harder, because you can't take 1/3 times 1/3 times 1/3 to something, so we probably are going to have a negative number here. All right, so if I think of this as 1/3 to the x, that's the same as saying 3 to the negative x. Well, 3 to the positive 2 gives me 9, so x has to be -2 because -2 makes -9. Okay, or sorry, -2 makes +2, which means 3 to the second makes 9. Okay. On the next one, do your loop-de-loo. 6 to the x equals 6. Well, clearly x has to be 1 here. Next one, 8 to some power equals 1. Well, anything to the 0 power equals 1. So x has to be 0. The next one, so we have 2/3 to the x power equals 8 over 27. Well, if I look at this, if I did 2/3 times 2/3 times 2/3, I would end up with 8 over 27. So x had to be 3. Then the last one, if I do my loop-de-loo, I get 4 to the x equals -16. Oh, look at that. You can't raise 4 to an exponent and get a negative number, so this is not possible. And then remember, I said you can't have negative logs, okay? So that means you cannot do this one. So x is no solution. It's not possible. All right. So now you're going to get a chance to try some problems out on Delta Math, and then in class we'll make sure that you understand this in better detail. So if things are still a little fuzzy, Just at least try the problems out, see how much you actually did absorb, and then in class, make sure you ask questions. We will make sure that before it's all over with, you are in much better understanding of this topic.